In this demo video, we focus on improving road safety by addressing distractions caused by using phones and smartphones while driving. We use smartphone and smartwatch sensors, phone cameras, and AI to detect drivers' distractions through secondary tasks and promote safer driving habits. We've created an app that allows drivers to record their distracted driving data, review past trips, and deploy neural networks right from their smartwatch to detect distractions. Virtual Vehicle has developed an app to detect smartphone movements when the phone is lying on a flat surface or when it is being used.
For demonstration purposes, simple AI models were created. After starting the tracking in the app and waiting a few moments, a model from the database to detect rotations of the smartphone when lying on a flat surface is selected. While rotating the smartphone, a sound indicates that the model senses rotation. Simple movement in the air is not detected. It is also possible to select another AI model from the database to detect movement in the air. This time the phone does not detect rotation, but movement in the air is detected and indicated by a sound. Stopping the tracking stops all the activities.
The smartwatch app we developed is called Autofocus. When starting the app, the user may choose to start a new trip or see information about previous trips. This information includes trip start and end times, duration, and the number of times the driver was distracted.
During your last 40 kilometers, you were 8 times distracted.
RISE has gathered driving and distraction data from trips using the Sensor Logger app, including common sensors on the phones and watches such as accelerometer, gyroscope, and GPS, and smartphone cameras. RISE also developed a video labeler, which then prepares the data for AI modeling, which includes training, testing, and validation. The AI modeling part was done in collaboration with Virtual Vehicle in Austria. The trained AI model is subsequently deployed in the field, enabling distraction detection on a smartwatch. The AI model operates exclusively on the watch. The driver data can also be deleted by the user at any time, ensuring data privacy and security. When a driver begins a new trip, they simply press the Start New Trip button. This action activates the app, which utilizes the watch's accelerometer, gyro, and GPS sensors in conjunction with a locally deployed AI model. The AI model is designed to recognize driver distractions, particularly arm movements that signal activities like prolonged watch gazing, usage, or interacting with the watch. Any detected distractions are securely stored on the watch for later analysis by the user once the trip is over.
TA2Every developed a computer vision-based model for predicting drivers' distraction, for helping the annotators to be more efficient while using the video labeler developed by RISE, and also producing a baseline to compare with the models which are deployed on each smart devices. To train our model, we use a combination of an open dataset and a private one where the smart device distraction classes were added. The model trained on the openly available dataset gives very strong performances. To enable an additional data privacy, we trained our model in a federated learning setting, meaning that the data remains locally and the model are transferred to the server only. As devices are low resources, we use quantization techniques to make them smaller and more efficient. Here is an example of our prediction with the 3 classes which are driving safely, using the smartwatch, or using a phone.
JIG Advanced Solutions has worked in developing the driver trainer web application, merging data from various origins, including smartphones and smartwatches, via the FiWare technology, and converging them into a unified web interface. After the completion of several trips, both drivers and fleet owners can conveniently access trip details such as departure and arrival points, date and duration, distance traveled, and incidents of distracted driving. This has the benefit of, after the incident, increase the public awareness, and it gives the possibility to educate drivers on the frequency and severity of risks taken with distractions during driving.
In this video, we demonstrated the work produced in the InSect project by two research institutes, RISE Research Institutes of Sweden and Virtual Vehicle, and two companies, Tietoevry and JIG Advanced Solutions.